Hello students, welcome to the second lecture of gravitation. We know when something falls freely to the earth, it falls with an acceleration that's g equals to 9.8 meter per second square, which is called the acceleration due to gravity. And gravity is the force with which the earth attracts any particle or any object towards its center. Okay, so if there is a body of mass m, let's say, it is attracted by the earth with a force which is called the gravity or the weight of the body, which is given as the mg, m into g, where g is the acceleration due to gravity, m is the mass. So here one important thing comes, which is the differences between mass and weight of a body. So often when we talk about the weight of a body, we just simply say that the weight of a body is, let's say, 100 gram or 100 kilogram or 2 kilogram or something like that. But that's technically not right, because gram or weight, kilogram, these are the weight, these are the units of the mass. So let's talk about the differences between the mass and the weight very quickly. Okay, so basically, if we draw the differences between the mass and the weight, what are the things? First thing is that mass is the amount of the substance that is present within the body. It's an amount of substance. Okay, so that's, we can say that amount of substance amount of substance that is present in the body, whereas the weight is the force with which the earth is attracting any object towards its center. Okay, so it's a force with which the earth is attracting any object towards its center. Okay, secondly, mass is a scalar quantity, okay, because mass is simply m. Okay, it's simply the amount of substance, so it doesn't have any direction, it has only the amount of quantity, whereas the weight is a vector quantity. Okay, then we can say the units of the masses in SI is kilogram, whereas in CGS it's gram, and the units of the weight in SI is actually Newton, or we can say kg weight, and CGS it's dyne, or we can say gram weight. Okay, this is simply represented as m, which is a scalar quantity, whereas the weight is represented as the force equals to mg. That means when we multiply the mass with the acceleration due to gravity, then only we get the weight of the body. Alright, so what is weight of the body? Weight is the force with which the earth is attracting any object towards its center, or the gravitational force of the earth on an object is called the weight. Okay, so these are the differences between the weight and the mass. Alright, in the previous lecture we have found that G equals to capital G m by r square, where G is the universal gravitational constant, capital M is the mass of the earth, and capital R is the radius of the earth, and the value was found to be 9.8 meter per second square. Okay, anything that falls freely from some height entirely because of its weight, that means there is no other force on that body except the weight of the body itself. Alright, such a motion of the body is called the free fall of the body. Alright, when there is no other force acting on a body except the weight of the body, then the motion of a body which is falling from some height is called the free fall, and whenever a body freely falls from some height, its acceleration is given as g, or 9.8 meter per second square, or sometimes for the sake of our problem solving we can take it as 10 meter per second square. Okay, so that's the free fall. Okay, now we will be talking about the equations for the free fall, because it's a motion of a body in one dimension, in one dimension. Yeah, so we can apply the equations of the motion to this. Okay, equations of motion. What are the general terms of the general equations of motion? We know that there are three equations of motion. Number one, v equals to u plus minus a t, where plus is for the acceleration, minus is for the deceleration. V is the final velocity, u is the initial velocity, t is the time, right? And then secondly, s equals to ut plus minus half a t square, where s is the displacement of a body, u is the initial velocity, t is the time, a is the acceleration of the body, and again plus for the acceleration, minus for the deceleration. And then the third one is v square equals to u square plus minus 2as. Again, v is a final velocity, initial velocity, a is the acceleration, s is the displacement. Okay, so these are the equations, general equations of motion. We have already derived this both numerically and graphically. You can have a look at those lectures. Okay, now when something is falling vertically, the motion of a particle which is vertical, let's say something is falling or something is thrown upward. All right, we can write these equations of motion for the vertical motion of a body as, because for the vertical motion the displacement we can write as the height. All right, initial and final velocity, of course v and u we can simply write as that, and then the acceleration as g, a is replaced as by g, and t as it is. Okay, so the equations becomes v equals to u plus minus gt, then h equals to ut plus minus half gt square, and then this is simply h. Okay, then v square equals to u square plus minus 2gh. So these are the equations for the vertical motion of a body. Okay, all right, g plus is for the body, for the acceleration of the body, that means when the body is falling down. Okay, minus is the deceleration for the body, for the deceleration of the body, that means when the body is moving upward. All right, mind it. We will solve couple of problems here maybe, and then we will check these equations, how to apply these equations. All right, so let's solve a problem now. Let's consider a problem where a particle is an object, let's say an object is thrown upward with some velocity and it reaches a height of 10 meters. Let's say it reaches the height of 10 meters. All right, and then of course it comes to rest and then comes back. Okay, so the particle, the question is, what was the initial velocity of the body, initial velocity which we will consider as u. What is the final velocity of the body? Final velocity of the body, and then how much time it took to reach the maximum height. All right, now maximum height is 10 meters here, so h equals to 10 meters, which is given here. Okay, now when something is thrown upward, we know that the particle, the object decelerates because the earth is attracting the body downwards, whereas the body is moving upward. That means the acceleration is negative or deceleration. All right, so g is negative here. All right, that means the velocity of the particle object slowly decreases and then it comes to 0 at the maximum height. That means here v equals to 0, u is something that we have to find. So this is already the answer of the second question, which is the final velocity of the particle, which is v equals to 0. Okay, for the first question, initial velocity u, we know the final velocity v equals to 0. We don't know the time yet, we will find the time. So before that we will apply the equation where there is no time here, because you don't know the time yet, right? So we will apply basically the third equation where there is no time here. So third equation is v square equals to u square. Here, because the body is decelerating, we will apply the minus 2gh. All right, therefore v is 0 here, so it becomes 0. So it is u square equals to 2gh, which gives u equals to root over 2gh. Remember that this is the general formula for the maximum height of a body which is moving vertically upward with some velocity u. Okay, so this is the general formula of a particle for formula for the particle for the initial velocity of the particle, which is whose maximum height is h. All right. So here u becomes root over 2 into g will consider as simply 10 here, because that will make our life easier, because nothing is said here, and h is also 10 meters. All right. So it becomes 10 root 2 meter per second. That's the initial velocity of the body. Okay. Okay. For the second one, we have already found the answer. For the third one, time. For the third one, that asks how much time it takes to reach the maximum height, right? So we will simply apply v equals to u minus gt. Okay, v is 0 here. That means gt equals to u, which gives t equals to u by g. All right, and again that's the general formula for the maximum for the time taken by a particle moving upward to reach the maximum height. All right, u by g, which is given as u is 10 root 2. We have just found that, divided by g is 10. All right, that's a second. So 10 cancel. So we have t equals to root 2 seconds. All right, so that's our answer. So that's how you apply the equations of motion for a vertical motion of a body, and then solve the problems. Okay, so let's quickly find the general equations, general formula for a body which is moving upward or downward. Okay, let's say a body of mass m is thrown upward with an initial velocity u, and then it reaches the maximum height h after time t. So we will find the general formula for the maximum height of the body and the time taken. We have already found the time taken, though we will find the maximum height here. Okay, so here v equals to 0, u equals to u, of course. So we have v equals to u minus gt, that gives us t equals to, this is 0, t equals to u by g. That's what we have just found in the previous problem, and this is the general formula for the time taken, time to reach the maximum height. This is the general formula that you can simply apply in anywhere where the body was moving upward and reach the maximum height. This is the time taken by the body to reach the maximum height. Now what is the maximum height here? Maximum height we can apply simply by applying the equation v square equals to u square minus 2gh. Now v is 0 here, that gives us 2gh equals to u square, therefore h equals to u square by 2g. That's the equation for the maximum height reached by a body which was thrown upward with an initial velocity u. Okay, so these are the equations, these are the formula that you can simply apply directly. You can apply for a body which is moving vertically upward. All right. Also, we can find the maximum time, the time taken, the time of flight. Okay, because the particle will move upward, it will reach the maximum height and then also it will fall down, right. So, what is the time of flight? Time of flight means what? Time of flight is a time for which the particle or the body remains in the air. Okay, and then we can from the problem itself we can see that it takes some time to go upward and the same time to reach to come downwards, right. So, whatever time it takes to reach the maximum height, it will take the same time to come back to the ground. That means the time of flight time of flight is given as capital T is given as time to reach the maximum height u by g, or 2 into the time taken by the body to reach the maximum height, which is given as T equals to 2 into u by g. So, that is the time of flight of the body. Okay, that is the general formula. Okay, so these are the formula that you can remember to solve the numericals from this chapter. Alright, you can simply apply the equations of motion and you can also find these equations and then apply them. Alright, so that's all for today's class. See you in the next class. Till then, take care. Bye.